is a video about assignment number 10, how instructions on how to attack any of the problems that are on assignment number 10. So here we go. Number one, this is the force on a desktop and the area is given. So the force on the desktop is going to be, as we know, the is going to be the pressure, which is given here, times the area. And you have to calculate it in newtons, then you have to convert this force to pounds, and then the answer of why this huge force does not crush the desk. Well, because if here is the desk, and this is the pressure from the air above, there is also air below that balance everything out. Now you have a box, number two, you have a box that it has dimensions. The following dimension has a length, has a width, and it has a height. So this is roughly your box. So the dimensions are given all here. And you take the air out of the box in a way that now the pressure inside the box is given by this amount here. So the question is how much force is required to lift the lid at sea level. Well, at sea level, the pressure from the top is going to be the atmospheric pressures at sea level. So that is probably like this value over here. So the difference between those two pressures, so the force that you need to lift this up is going to be, you see, this pressure is associated with a force down. This pressure is associated with a force up. So the difference between these two, you have to add a force here to lift the, so the force to lift it is probably the pressure difference times the area, of course. And if you now go to a place in which the atmospheric pressures changes, then this value is going to change and you probably are going to need less force than at sea level. In question number 3, you have, this is a question of the hadronic lift. We actually did a lot of this in lecture. And so you have a car in that it has a certain weight over here. So it has a certain weight that is given by this, and the this is the large piston. So this has a radius of 10 centimeters, this one here. So this is R1, this has radius R1, and this will have the radius R2. And so which is the force that you have to apply here? Well, the force that you have to apply here is such that you have to have the same pressure here at the pressure that you have there. And the so the pressure here, it will be the force that you are looking over divided by this area here, which is pi r squared to r squared, and that has to be equal to the pressure here, and the pressure here is the weight of the piston divided by the this area over here. So the so that's basically how you find this force. Now you move this a distance, this move up another distance, and the work done is the same. So the work is either is this force here times that distance. So let's call it this F2, and this has to be equal to the force on the other side times the distance on the other side. So this is how you find now the distance. And the ratio of this force to the ratio of the work to this force, this is called the mechanical advantage. So this number is actually always larger. This number is greater than 10 or something. So it will depend on the specific number that you have in your problem. This is a problem of the brake. So this is how a brake works. You push here with a center force. This moves a little bit, and then these actually move pistons that are over here and help to stop. They push the brake pad into. So the point is that the pressure is the same. So when the force applied by the brake to the small piston is 7.7 Newton, you want to know what is the so these pistons here are this piston here, and this piston here is this. So this piston is smaller. So the pressure here is this force F that is known. So for example, in my case will be 7.7 newtons, and then you will have to divide it by this area, which will be 2.3. That's the pressure. And that's the same pressure that is over here. So now there is another force here because there is a different area. So that's the force that you compute. And now there is friction. It's the friction force that stops now this from rotating. The friction force is mu times the normal force. This is what you found here. So you found the normal force in part A. They tell you what is the coefficient of friction. So the torque to stop, it will be, you see this is the force of friction is somewhere in this direction here, and this is the radius. So the torque is twice this force. The total torque adds up. So the torque from one side adds to the torque to the other side. The force is that, and the distance to do the torque is this distance here. This is the distance that you are from the axis of rotation, this distance here. So all of the numbers are given, so that should be pretty straightforward. This is a problem of how pressure actually changes with depth. So if the pressure at the top is this, the pressure, and you want to know this pressure, then you can calculate the height. It's just the difference in the pressure divided by rho g. The number 6, you have to be careful. Here they are asking you what is the pressure increase, so they really want that. So when you are going 35.1 meters, the increase on the pressure is simply rho gh, and the h is already given. This is the other way around. This is going up, so the pressure is going to decrease, and the amount that is going to decrease is going to be negative, and it's going to be the density of the air times g times this height here.